All right. Good afternoon, everyone. Welcome to Improving Talks. This is where we deep dive into the world of technology with brilliant minds like our speaker today. I'm thrilled to introduce Juan Cruz Fortunati, a full stack engineer and AI consultant with Improving here. He's got over a decade of experience at companies like TriNet, PayPal, and Disney. But he's also a digital nomad. He has been overlanding across South America and taking great photography of architecture, landscapes, and the night sky. And I can't wait to see those sometime, Juan Cruz. Um, yeah, so we're going to be talking about from fragmented knowledge to unified insights, the power of clean data. Join us as Juan Cruz shares strategies for advancing data cleaning, synthetic data generation, and bias mitigation using a real world project, a call center chatbot. He'll show how legally approved but disjointed knowledge articles are transformed into a unified training dataset. Now, as you get settled in for this talk, I want to bring your attention to the Q&A button at the bottom of the Zoom interface here. This is where you can submit questions to JC. I'll collect up those questions and read them to him at the end for him to answer live. And so now, without too much ado, let's explore this topic with Juan Cruz. Why don't you take it over?
Thank you, Daniel. Thank you. And hello, everyone. Thank you for joining today. My name, as Daniel said, is Juan Cruz. You can call me JC. For short, that is easier in English. And today we are going to be exploring how transforming fragmented data into unified insight can greatly benefit your AI strategies. We'll focus mostly on data quality and how it directly affects your AI outcomes. So, Daniel, if we can go to the next. Thank you. So, let's start with the index. First, we are going to talk about why data issues matter, see some key figures and frame the problem there. Then we're going to talk about solutions like data cleaning, synthetic data, and ways to reduce bias. This is a huge problem. And after that, we are going to show a real world example involving call centers. And the idea here is that we are going to talk about a few of these concepts, not all of them, because real world examples actually do not actually overlap with the perfect world where you can go over and implement everything. And then if we have time, we are going to go to this Q&A and share some best practices at the end. Okay, the challenge, right? Why data issues matter. Imagine that you're trying to build a house, right? This start with an analogy, why not? No matter how strong your house is, if you have an unreliable foundation, the house is going to fall probably, right? It's going to. So the same thing is for AI models. You need a strong foundation with the data that you bring into the model. So even the best models will fail with poor data quality. So we can go to the next one, Daniel. Thank you. So according to Gartner, on this study that they shared on 2023, poor data quality costs organizations, an average organization, around $13 million every year. So this isn't just something to not consider or just to hide on the rug. It's a real financial problem that organizations must take seriously, right? Depending on the amount of data that they have. For example, if we go over from companies to the whole economy, according to IBM, the bad data basically costs $3 trillion every year to the whole economy. If we can go to the next one, thank you. So it costs $3 trillion. That's about 11% of the GDP. So this isn't just investing in data quality isn't practical. It's practical and profitable, right? It's not only that, but not only for companies, but also for whole economies. Okay, let's go to the next one. Thank you. So without clean data, what happens? or what are the actual reasons for the noisy data? Let's say you can have things like, for example, missing or noisy data, where you have gaps, duplications, or errors, and these, as we said, are unreliable foundations for the AI. Then also the bias, potential bias that you can have in your data, for example, that can lead to unfair outcomes and raise serious ethical and compliance risks. And then on the other hand, as the case that we are going to showcase later, fragmented knowledge, right? You could have different sources saying different things, or they could be sliced across different systems, and that could be hard for models and for systems to get a complete look onto that, right? A complete sight onto that. So what leads this into? Inefficient workflows, basically manual searches, repeated work. It's going to slow down operations and decision making. So that's why, I mean, regardless of AI or not, we have to have clean data. So here, the following topic, let's think about what cleaning the data is and how you will do it. But let's first frame it on a few quotes that I have from some sources. If we can go to the next one, Daniel, thank you. So according to a KD Nuggets article, automated data cleaning, right, on your data sources can lead to a 25% increase on AI accuracy. So this is, of course, is a huge benefit, 25%, but you have to consider the costs, all right? Because maybe trying to have that 20% costs a ton. So yeah, because you have to iterate this, right, and implement the automated data cleaning. Then, on the other hand, according to this research paper on 2019, building documentation, not just for data cleaning, right? I mean, you can talk about documentation for any kind of step of software development, but specifically for data cleaning. Sorry, but yeah, apparently some of the numbers on these slides moved. But the idea is that documenting your data cleaning processes lower or reduce the rework time by amount of 40%. So again, that's saves time, saves cost. So it's quite good to implement these features if we can. So how do you handle data cleaning, right? What is it actually? Okay, so there are a few methods and a few things that we can consider. For example, let's say that you have this fragmented data or missing data. You can do amputation or outlier handling, right? Basically, removing points that could be outside of the distribution of the data. It could be due to errors or to something that was wrongly filled. And then imputation, because, of course, you can fill missing spaces with, for example, human-in-the-loop systems. Then you can go ahead and do noise reduction, of course. For example, removing random errors, doing, for example, smoothing or clustering of the datasets and removing outliers on that. And then, in order to do this, we will use tools like, for example, Pandas for reliable transformation, Dask to handle these transformations on large-scale datasets. And then OpenRefined, it's a tool to do interactive and visual data cleanup. So that will be helpful also. So let's go to the next subject. And this is synthetic data cleaning. Synthetic data generation. Basically, this will help us when we have maybe very few amounts of data points, or maybe we have very little data points on some piece, some part of our data set. And also because we can create fake data, right? For example, if we are dealing with some kind of data set with real profiles from users, we can actually craft fake profiles for users and then train our models with that based on the actual distribution of the data, and then go ahead and train our models. So this actually improves safety, right? So according to this study on 2022, using synthetic data, a group of banks use this to simulate some rare fraud cases, right? And with that, the models learn to catch the edge cases better, and this lead up to a 20% increase on finding these fraud cases. So that's actually huge, just by, as I said, generating these maybe these places where you have less data points, right? And you have to generate, and you can generate them using these methods. So another study from Gartner in 2021, they say that 70% of organizations using synthetic data reduce greatly reduce the privacy compliance issues. So this is more like a qualitative measure, right? But again, using anonymous data, it's always going to be better, right? Because you are not using your users' data to train the models, and thus you are not exposing that information, and you're not creating bias maybe that could be there, and you can control a bit more the actual data set, at least for when you're dealing with real people data. Okay, let's go to the next one. So how do you create this synthetic data, right? For example, we can use several techniques like generative adversarial networks. These are networks that they play like a game. One generates information and the other checks that information, and they play this game of generating and evaluating, and then come up with the solution. Then you have these variational generations, or actually this is mode, for example, that is interpolation, and they help let's say extend or augment your data. Then the benefits for this is that you're going to have you're going to protect privacy. You could lower down cost because you don't have to do acquisition of data, and maybe the acquisition is too costly, so you can do the generation. And then, since you can generate data points on any piece of the spectrum, let's say, or any piece of the cases that you want to cover, you can improve on coverage. But that is all pretty butterflies and colors. The actual real problem is that there might be a synthetic gap, right? Because maybe the data generation that you are doing is not actually what it's seen on the real world. So this is called synthetic gap, and that could have some risks. And then, of course, that in rare cases scenarios where you won't have much of data, this is the best way in order to overcome those cases. Okay, so lastly but not least of this theoretical part, let's say theoretical rundown, we're going to discuss bias. Bias is not just about a technical part of the problem, but it's more like a human problem, right? Because what is truth, right? I mean, what is truth, and also what is actually the correct answer? Maybe if you define the correct answer, or maybe if you have the correct answer and you have all the possible cases, you can lead to something like that. But since it's pretty much text, for example, for LLMs is pretty much opinions, right? It's hard to mitigate this bias from the data sources. So let's go to the next slide. And according to Accenture, on this report on 2019, 1 in 3 AI deployments suffer reputational damage because of bias. And so this isn't just costly. I mean, it's harmful for the brand, right? I mean, this is going to hurt trust on the brand. Let's say, imagine that you deploy. I mean, 1 in 3 deployments is going to end up in Twitter with a bad tag on your company name or on your solution name. So this is actually huge. These problems with bias. So in the following slide. Yeah. So there is this other study that this is quite a big one. This is one of the big one by Bola. Sorry, but the name is hard to pronounce. Bolami and Gibru on gender shades on 2018. They show that for certain groups, for gender and ethnicity, facial recognition errors can be up to 30% for some groups rather than others. So this is not just like a small issue. I mean, imagine that you go to the airport and you get flagged by security just because of you look differently, or maybe because there are more data for certain groups than others, right? This is one of the key points. I mean, when models are trained with more data for some groups and not for others, these are the real issues that you could have. So, how do we what are actually the sources, and how do we mitigate this, right? So the sources for bias can be sampling errors, basically how you're collecting the data. Maybe the sources that you're using are skewed, or maybe the sources that you're using represent more a sample of data and not the whole cases of data that you can have. Also historical bias, and then poor measurements, right? Again, the way that you where you get this data. Then you can act before, during, and after the training, right? You can do pre-processing of the data, in processing while you're training, or you can do post-processing and remove these biases. And then there's a few tools by IBM and Microsoft that let you handle this. And also there are some guidelines by the EU AI Act, and also the Google principles that will assist you with that. Okay, so let's go to the actual practical sample, and let's frame this into a real world case, right? So we had this problem with a RAG assistant that we had to build for an HR company, a third-party HR company. Basically, what they did is offer HR services for other companies. So we were tasked to create this RAG assistant, right? And the RAG assistant was intended to be used by the call center agents in order to retrieve information that they needed to use to reply to the questions of the people that were calling to the call center, of course. I mean, up to this point, what the agents were doing was manual search, right? Manual search on Salesforce and some other services. And we're trying to retrieve the information and reply the questions there on the hotline. The issue was that maybe the more less experienced agents, or the new hires had to ask for help to more experienced agents, because the data sets on Salesforce and other services was actually poor or lacking or fragmented, right? So this is what we are seeing here. They had scattered data sources. They had a bunch of files that were incompleted or maybe overlapping, or they didn't have the information, and you had to retrieve maybe several files in order to perform one reply that should be actually in one file, for example. And there also were missing topics and overlapping documents. So this was the problem with that data. So what we did to solve this, and here we have a high view of the technical solution that we went with a first naive approach, right? Basically, we gathered the resources. We went with Salesforce documents and call transcript. We gather those, we chunk them, right? Basically what you do is you grab the documents, you grab a piece of the document, and then you use that and you call that a chunk, right? A piece of the document, and maybe you do some overlapping, and then you embed that. Basically, the embeddings that we use basically transform the text into numbers, a vector, right? And then you can put that vector with an ID referencing the chunk that you use to construct that vector into a vector database. Then the RAG system can use these vectors in order to retrieve information whenever you ask a question to this RAG system. Basically, I mean, see, if we see it from the Raga system, I know that this is not the topic of the talk, but we can also give the context. Basically, what the Raga system will do is a question will come in, we embed the question, and then we use that embedding of the question to retrieve the passages or the chunks that match that passage as close as possible, and then we are going to find the documents where those chunks came from, and we are going to use that as context for the model to reply, right? There was a problem with that, and the problem was that as we discussed before, the Salesforce documents were disjointed, or they had overlaps, or actually the data was missing, and that was a problem because we couldn't make the LLM reply to the questions that we were trying in a cohesive way or consistent way, because it always found out different chunks or different data sources, and they were conflicting between each other. So what we did, this was the second plan, the iteration after we saw that. And let's frame this. Actually, this is a context that I didn't give. This was at first of the AI wave, or the later AI wave, and we were using GPT 3.5, so models weren't as capable as now with reasoning models and etc. So maybe this in today's framing will be a lot easier, but back then we had to do a lot more handling of the rephrasing, etc. So what we did, closing parentheses, let's go back to the second plan. And basically, we put a new step in the middle. And instead of using directly the documents from Salesforce and from the call transcript, for example, we crafted new documents, right? Putting up together finding the information and replying to questions using these documents, creating basically a new data set, right? We found out questions within the data set itself, and then we crafted documents replying those questions with the data, thus creating a new data set of synthetic data based on the actual documents, right? Then we chunk those new documents, and then we keep the rest the same. That improved the replies of the models because now we didn't have conflicted views, etc. But if we go to the following slide, and if you remember that in the previous slide, I had this empty square on the bottom right, we had a new problem that actually the documents that were disjointed and that were bad handled and etc. were actually legally approved. So they had like locked words, that a locked language that we couldn't change. That put quite the roadblock for us, because now we have this synthetic data that we couldn't use to reply to the questions that the agents were doing. So what we did is to come up with that third approach. Actually, it was like fifth or seventh, because we had quite a few iterations. But if we can go to the following plan, yeah. So we came up with this third approach, where we keep the idea of the second approach, but we added the references to the broken articles or to the original articles tagged with the what you will have is basically the new synthetic article with the references to which articles provided the context in order to create that new article. So whenever we make the agent reply to questions, we will retrieve the information using the synthetic data in order to use it as an index, and then we will reply using the broken references. Let's call them that because it's actually what they were. So that improved a bit because we had the broken references used as the actual source for the replies. So that was more aligned, but still we couldn't control pinpointing exactly what the LLM was saying, because the LLM would rephrase anyhow. So it was, but it was more balanced. At least it wasn't all synthetic. So that's on the showcase of this. So let's go to and summarize the key lessons. So something that you always have to do is to document and cleaning, document and your cleaning and generation steps. Actually, in our solution, we had to go over and create several Google Colabs and Python notebooks in order to try and test prompts and etc. And something that we realized really soon, it was that we had to keep track of the prompting, keep track of the ways that we were generating the data, embedding, chunking, clustering. All of that has to be really documented. And I believe this is more crucial actually on AI and data cleaning and data generation, because later on you have this synthetic data and it's not like logical, like in usual development, but rather, for example, I mean, because we're working with LLMs, right? I'm going to frame it as that. But since it's a lot more variable, you should document everything. Prompts, data, how do you handle the pipelines, everything. And that's going to improve a lot, because then you are going to be able to replicate and be able to fine-tune your workflows. Then when you bring this into scale, right, you should iterate and monitor constantly, because let's say that you implement your model, the pipelines are going to change, the way that your data is going to be acquired, it's going to change. So the data is going to evolve continuously. So you should try to iterate and monitor if your models are still doing the cleaning as they should, if you are catching the outliers, if you are catching or the clusters moved maybe. So you should be always keeping and iterating constantly on your data cleaning, for example, data cleaning practices. Oversight is essential. This is true. And actually, something that I didn't mention on the previous step, it was that one of the key aspects that we iterated at one point, it was to have the agents that were trying the bot, the RAG agent, to write the replies, if the reply helped or not. And that will and we track those feedbacks, those human feedbacks, to be able to help with the generation, the data cleaning, and iterate a bit on the processes, and that's fine tuning the process of data cleaning, data generation, data synthesis, and also embeddings and all of the rest of the topics. And also stay ethical. I mean, this is actually crucial. Maybe our models, since it was or systems, since it was just within the company, it wasn't going to be published or anything. We didn't have to face this that much. But again, we had this issue with legal that we didn't saw it before, because we didn't think about this. This was pretty much on the beginning of these kinds of systems. So yeah, this is a key part that you should track. Yeah, we can jump into.
Okay, well, so far we haven't had any questions come in, but I'm really enjoying your talk. This is a fascinating topic that I think is very timely too. Improving is getting into this AI space. Sounds really exciting.
Yeah, it is. And there are things coming out every day, right? That you have to keep your ear there on the wind. For example, yesterday there was a few new models. Like on Monday, I believe that DeepSeek released a model.
Yeah.
Yesterday, Google released the version 2.5 of Gemini. So yeah, every day you have new players around.
Yeah. So yeah, it's kind of a full-time job just to keep track of all the new developments and what they mean for the industry and how they can be applied to our clients, our work, all these things. Well, I'm not seeing a whole lot of questions. Let me move on to the final thoughts.
Yeah. So here we have a quote from Deloitte Global on a survey that they did on 2020. They say that AI-driven companies that prioritize data quality report a 35% higher revenue growth. So basically, this is a key summary on that. Data quality is like the groundings for everything that we discussed up to now, right? The data is key in order to build this kind of systems. I mean, this was framed as a RAG system, but you can do it as a classification or any kind of recommendation system, etc. It's going to be the same, right? It's going to be analogous. So a clean data set, it's going to mean that you have a better AI system, better decisions, and better outcomes. So yeah, clean your data. That's basically the summary of the talk.
Oh, absolutely. We did have one question that just came in.
Okay.
It says, for the human oversight, is it
Yeah.
possible to have the human agents to write the correct answer and save somehow to improve the model quality?
You could totally do that. Yeah, for sure. Then you will need to think on how you implement those feedbacks as
Right.
this reply in your workflow, and how you iterate on that, and how you include that in your data sources. Let's say, I don't think that maybe, I mean, because let's consider the case, right? Maybe this agent provides some kind of the actual reply to the question that he asked, or maybe the fix on the reply. But
Yes,
then
right.
it's just one data point. Maybe he's biased. So you actually need to start to leverage a lot of replies, and then see how you can use those lots of replies in order to incorporate them on your data set.
Yeah, that makes a lot of sense.
Okay, so thank you for joining, and thank you for caring for data quality and data.
Yes. And I thank everybody. Let's all thank Juan Cruz for his insights into this clean data strategies topic for AI systems. It's been very enlightening, and I think it's very actionable too for those of us working in this space. We really appreciate your passion for turning fragmented knowledge into powerful insights. Before we wrap up, let's give you some information about the upcoming talks. Here in April, we're going to be starting a new topic. And on April 2nd at 12 Central, the topic will be ERP consolidation into SAP. Where Improving will showcase our expertise in integrating multiple ERP systems for an agribusiness. We used Snowflake, dbt, HBR, and HighTouch to standardize data across platforms, ensuring a unified finance function. You don't want to miss that, so join us next week. That's April 2nd at noon Central. Yeah, and just keep an eye out on the Improving Webinars website. That's improving.com/thoughts/webinars. And all our upcoming talks are available to register there. And you can also see links to our past ones and catch up on all the stuff that you've missed so far. Now, I wish everybody a good day, and you guys have a wonderful day.